Welcome to this explainer. Today, we're doing something a little different, something absolutely critical. We are engineering the perfect DNA of an answer for Cambridge Computer Science 9618, specifically decoding exactly what examiners are hunting for when they test laser printer principal operations. Look, we're going straight to the core insights from principal examiner reports to uncover the proven strategies that separate the average candidate from the truly exceptional. We see two types of students all the time. There's Alex, who overloads every single answer with raw hardware facts but provides zero actual analysis. And then there's Sam, who just rushes through, panics, and completely misses the specific command word requirements. Both are leaving massive points on the table. So, if you've ever wondered how the top-tier students consistently hit those upper mark bands without breaking a sweat, you are exactly in the right place. We're going to transform your approach from a chaotic brain dump into a highly structured, point-scoring machine.
Okay, let's just quickly scan our agenda for today. We're covering the 15% mastery, core theoretical principles, the method mark strategy, critical analysis and evaluation, and wrapping up with the top 3 examiner warnings. Let's get right into it.
Section 1. The 15% mastery. We are starting here because this is a high-stakes exam strategy, plain and simple.
Now, listen closely to this number. Laser printer principal operations accounts for approximately 15% of your total marks on paper 2. 15%. Just pause and think about that for a second. That is literally the difference between an average grade and an A-star result. It's a massive, massive chunk of your overall assessment sitting right here in this single topic. When one subject area carries that kind of weight, you absolutely cannot just rely on memorizing a few bullet points from a textbook and hoping for the best. You need a targeted, engineered approach to studying it. You have to know the precise sequence, yes, but you also have to know how to structure that knowledge to perfectly align with the marking scheme.
So, this brings up a fascinating question. A senior examiner recently highlighted a really profound stumbling block. Why do so many students struggle to correctly sequence the exact physical and digital steps of this operation? It's a huge challenge, year after year. Well, before we continue and reveal exactly how to fix this, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, back to the sequence struggle. The secret to fixing this isn't in memorizing more flashcards, it's entirely about how you structure your thinking and decode the command words. By the end of this explainer, you're going to have the exact framework to sequence these operations flawlessly.
Moving right along to Section 2, Core Theoretical Principles. This is all about moving beyond superficial breadth and building serious depth.
The Cambridge syllabus doesn't just want facts. It demands logical, structured reasoning over robotic memorization. Look at this quote directly from the academic benchmarks. Top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. What does that actually mean for you? It means the examiners are actively hunting for analytical depth. They don't just want you to regurgitate a rigid list of how a laser printer works. They want proof that you understand the underlying principles so intimately that if they throw a completely unfamiliar scenario at you, say a strange network configuration or a unique error state, you can still apply those core principles to solve it.
And that brings us to connected understanding. This is the ability to link precise definitions and causal relationships to other areas of the syllabus. The theoretical architecture of a laser printer doesn't just exist in a vacuum, right? Principal examiner reports continually confirm this one fact. Candidates who reference cross-topic connections achieve significantly higher marks. For instance, if you're answering a question on a laser printer's data reception and you suddenly connect that to fundamental binary representations, or you start talking about hardware system interrupts, you are instantly signaling to the examiner, hey, I haven't just memorized this page, I actually understand how this entire computer system functions together. That is how you unlock the highest mark bands.
Let's jump into Section 3, the method mark strategy. This is where we get incredibly tactical about earning marks for your actual process.
Okay, this standardized sequence is your procedural framework. You identify the key elements, apply the relevant principles, execute your analysis with crystal clear working, verify your results, and present them in the correct format. This is where you bring in frameworks like PEEL, point, evidence, explanation, link. You make your point about the hardware, provide the evidence of the operation, explain why it happens, and link it back to the specific command word in the question. Following this systematic approach earns you method marks for your process. Even if, knock on wood, you mess up a tiny detail in your final conclusion, the examiners want to reward your logical, structured approach. You get credit for thinking like a computer scientist.
Mastering these specific hardware analysis essentials proves your ability to interpret complex data effectively. You need step-by-step sequence decomposition. That means breaking down the incredibly complex electromechanical printer operations from the initial charging of the drum all the way to the fusing of the toner. You have to accurately identify every component involved. You really need to understand the data management happening within the print buffer. And finally, you have to verify the logical progression of the output. If you can master this breakdown, you prove you can extract true meaning from the process. And honestly, that is exactly the kind of practical application this syllabus demands.
All right, Section 4, Critical Analysis and Evaluation. This is it. This is the A-level differentiator.
I want you to actively compare these two approaches. Stop scrolling, subscribe to our YouTube channel Ace the Exams, at @ACEXams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @ACEXams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, looking at this comparison, it's the stark difference between a superficial answer and true evaluative thinking. Remember Alex from earlier? Alex gives a superficial answer that just blandly states what happens. The laser hits the drum. Great, but so what? Top-scoring candidates, the ones using the perfect DNA framework, they analyze the process. They acknowledge the limitations of a specific hardware approach, and crucially, they justify their decisions with solid evidence. They don't just say one method is faster, they explain exactly why, carefully weighing the trade-offs in efficiency or resource management.
When you are evaluating a system's operation, you have to identify key performance factors. You do this to check for reasonableness and to make justified recommendations. You must evaluate the data transfer speeds. You absolutely have to consider the memory limits of the printer buffer. What happens when it gets full? You must factor in the output resolution, and finally, analyze the effect on overall system performance. If you are writing a paragraph and you aren't hitting at least a couple of these points when evaluating the process, I guarantee you are leaving marks on the table.
Furthermore, comparative analysis requires you to actively identify both similarities and differences. And here is a massive pro tip, straight from the grading room. You must use comparative connectives. I'm talking about words like whereas, conversely, or similarly. You must support every single comparison with hard evidence, always drawing clear conclusions about relative importance. Don't just list two things side by side like a bulleted list. Explicitly compare them. Tell the examiner which factor matters more in the given context of the question.
Let's move to our final section, the top 3 examiner warnings. We are going to avoid the classic traps together.
Look, pay extremely close attention to this. This is a massive alert directly from the examiners themselves. They report year after year that students constantly lose marks by failing to clearly define terminology before using it in extended responses. It is incredibly frustrating for an examiner to read an answer where a student clearly, conceptually understands how the printer works, but they use the entirely wrong, precise definition for a component. The whole theoretical architecture of your answer rests on these precise definitions. Always define your terms first before you launch into your deep analysis. So here they are, the top 3 mistakes you absolutely must avoid. First, confusing the sequence of operations. This is classic, mixing up when the laser writes to the drum versus when the toner is actually applied. Second, totally ignoring the role of the print buffer when discussing data flow. The buffer is crucial, don't skip it. And third, providing generic, robotic answers that are not specific to the question's actual context. Remember Sam rushing and missing the command words? That leads straight to mistake number 3. Examiners are looking for applied knowledge, not copied and pasted textbook answers that ignore the scenario they just gave you. To completely avoid those traps, encode this deconstruct, solve, evaluate methodology into your brain. Identify the given information, break it into logical steps, solve systematically, check for reasonableness, meaning ask yourself, does this answer actually make physical sense, and make justified recommendations. If you internalize this workflow, you naturally bypass those examiner warnings. Now, students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder, subscribe to our YouTube channel, Ace the Exams at AceTheExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @AceTheExams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.
As we wrap up this explainer, I want to leave you with one final thought. Ask yourself, will your very next practice answer just list robotic facts like Alex, or will it prove deep, connected, conceptual understanding? You now have the complete examiner's blueprint. How are you going to apply this framework to ensure you aren't leaving that massive 15% on the table? Take these insights, apply the method mark strategy, and watch your mark band completely transform. Keep practicing, keep evaluating, and I'll see you in the next one.